Welcome to the deep dive. So today we're tackling something absolutely foundational, the real bedrock of building anything successful, especially in the software world. Really understanding what our clients need and turning those sometimes fuzzy needs into concrete software requirements.
Yeah, that's exactly it. And we've got some, really insightful course material to dig into here. Practically a blueprint for getting software projects off on the right foot.
Like a blueprint, yeah. Think of this as your shortcut, right, for navigating that crucial initial stage.
Exactly. Navigating that stage and avoiding a world of pain down the line.
Absolutely. Because let's face it, nobody wants to invest all that time, energy, resources into building something that just misses the mark.
Mm.
So this deep dive is really laser focused on making sure we build the right product, that we get it done right, from the get-go, and ultimately that it's managed right through the whole life cycle. We're trying to cut through the ambiguity and get down to what really works.
Right. And just to give you a roadmap for our chat, we'll start by defining what a requirement actually is and the key things you do when working with them.
Oh, okay.
From there, we'll unpack the different kinds of requirements you'll likely run into. Then we'll spend a good chunk of time on, well, the really vital skill of understanding and interacting with clients.
Crucial part.
Definitely. We'll also look at practical ways to capture these needs, like user stories, how to make sure these requirements are actually, good quality, and finally, how to handle the inevitable stuff-changing needs and those tricky ambiguities.
Okay, so our mission today is basically to equip you with a solid grasp of how successful software projects really start with those crystal clear needs and give you the confidence to navigate all the complexities involved in turning a client's vision into, well, reality.
That's good.
All right, let's unpack this. Module 1, Introduction to Requirements. Where do we start?
Well, let's get a solid definition down first. The IEE, which is a big authority in tech fields, they define a requirement as a few things. 1, a condition or capability needed by a user to solve a problem or achieve an objective.
Okay, what the user needs.
Right. 2, a condition or capability that a system must meet to satisfy a contract, standard, or specification.
The system's obligations.
Exactly. And 3, a documented representation of either of those first two.
Gotcha. That's pretty comprehensive. So it boils down to what the user needs to do something or what the system has to do based on an agreement or standard. And having these clearly defined, that's the linchpin, isn't it?
It really is.
It ensures we're hitting the real needs and, preventing those costly surprises later.
Precisely. And getting to these well-defined requirements, it's not just one step. It's actually a series of connected activities. There are 5 key ones: eliciting, expressing, prioritizing, analyzing, and managing.
Okay, let's break those down a bit. Eliciting.
Eliciting is that crucial first phase, uncovering what the client truly needs. Expressing is then taking those sort of raw needs and putting them into a structured format.
Making them concrete.
Prioritizing helps figure out what's most critical. Analyzing makes sure the requirements are clear, consistent, make sense together. And managing is the ongoing piece, tracking them, adapting to changes as the project moves along.
Okay, that first one, eliciting, that feels like there's a real art to it. It's not just the client handing over a list, is it?
Oh, definitely not.
It's more about helping them figure out what they actually need, which might be different from what they first think they want.
Absolutely. That's a key distinction. Clients often come with wants features that sound nice maybe, but aren't fundamental to the core purpose. Needs are the essential functions. Without them, the product just won't do what it's supposed to do. Elicitation is really a collaborative discussion, a kind of exploration to uncover those core needs, and also to figure out which wants are actually feasible and add real value. It's definitely not just passively taking notes on a wish list.
Okay, so we're digging for the needs. Now, what kinds of needs are we talking about? I'm guessing they're not all created equal.
You're right, they come in different flavors. First up, you have business requirements. These focus on the big picture, the project's overall goals and objectives, often tied to measurable business results.
Okay, give me an example.
Sure. A business requirement might be something like reduce order processing errors by 25% to increase annual revenue by $10,000. See, quantifiable value.
Got it. The high-level business drivers. What's next?
Then there are business rules. Think of these as constraints or specific policies on how the product has to function, like government regulations, maybe data privacy rules, or even things like company branding guidelines that have to be followed in the interface. They basically set the operational boundaries.
Okay, the rules the product has to play by, and then we get to the actual people using it, right? The
Yeah,
users. What do they need to do?
exactly. Those are user requirements. They describe the specific tasks users need to accomplish with the product, what the product actually does for the user.
Okay.
These are often seen as super important, and a lot of time usually goes into figuring these out. We express them in different ways, use cases, user stories, sometimes storyboards, even just scenarios described by the client, though those usually need some refining.
So a client might say, my team needs to track leads easily. That's the start of a user requirement.
Precisely. That's a great starting point.
Yeah.
Then you need to figure out the specific actions the system has to take to make that happen.
And that brings us to?
Functional requirements. These describe the specific behaviors the product itself should perform. Think inputs, outputs, processing logic. So for that lead tracking example, a functional requirement might be when a user marks a lead as close won, the system must send a confirmation email to the sales manager. It describes a specific system action. Sometimes people use information flow diagrams here to show how things move through this system.
Right, like how an ATM processes your withdrawal request.
Exactly that kind of thing, showing the system's function.
So functional is what the system does, but then there's also how well it does it, right? Like speed, security, that kind of thing.
Precisely. And those are non-functional requirements. They describe the quality attributes, accuracy, dependability, security, usability, efficiency, performance, maintainability, all the abilities, basically.
Yeah.
So building on that email example, a non-functional requirement might be the confirmation email must be delivered within 2 hours of the lead status change. It's about how well the function performs.
Okay, functional is what non-functional is how well. Makes sense. Are there other types we should know about?
Yeah, a few more. External interfaces describe how the product needs to interact with other systems, maybe retrieving data from a remote database or something. Physical setting requirements cover how the product needs to function in its actual physical environment. Think like needing to be waterproof for underwater use or operate in extreme temperatures.
Right, the context it lives in.
Exactly. And finally, development constraints. These are limitations related to actually creating the product, things like supported platforms, maybe memory limits, specific tech stacks dictated by the client, or budget constraints.
Ah, okay.
Interestingly, with development constraints, especially technology ones, it's often best to address them as late as you possibly can. Tech changes so fast you don't want to lock yourself in too early if you don't have to.
Good point. Avoid painting yourself into a corner. Now, all these different requirement types, they need to fit into a bigger picture, don't they?
Absolutely.
Yeah.
That's where product vision and scope come in. The vision outlines the product's fundamental value, its purpose, its place in the market, the long-term goal.
The North Star.
Kind of, yeah. And the scope defines the boundaries of what this particular project aims to realistically achieve. Vision is the destination. Scope is the map for this specific journey. They're tightly linked.
Okay. And what happens when that scope starts? Well, creeping. We've probably all seen that happen.
Scope creep.
Oh,
Yes. The bane of many projects. It's that uncontrolled growth of the project's scope after it's already started, usually because new requirements pop up or existing ones change unexpectedly.
And it can wreck timelines and budgets, right?
Absolutely. It's a major risk,
Yeah.
but you can defend against it.
How? What are the strategies?
Well, first and foremost, clear expectations and constant communication are key. Defining the scope really explicitly up front, maybe using tools like use case diagrams to show what's in and what's out.
Drawing the line, clearly.
Exactly. Prioritizing requirements is also huge, so you tackle the most important stuff first. And critically, always asking that question when something new comes up, is this actually in scope? Having concrete timeframes for development cycles also helps manage expectations about what can realistically get done.
So setting boundaries and constantly checking them. Makes sense. Carl Liegers, who's a big name in this field, he had some really neat definitions for vision and scope, didn't he?
He did. Uyghurs called vision the long-term strategic concept of the ultimate purpose and form of a new system. Very aspirational.
Yeah.
And scope, he said, draws the boundary between what's in and what's out for the project. Just perfectly captures that boundary setting aspect.
Concise. And in agile development, the approach to change is a bit different, isn't it? It's not about just rigidly sticking to the plan no matter what.
Right. That's a core agile principle.
Yeah.
Change isn't seen as the enemy. It's often expected. The key is to evaluate proposed changes based on the value they bring. If a change adds significant value, Agile says, okay, let's figure out how to incorporate it, revise our estimates, adjust the plan. It's about adapting intelligently.
More flexible, but still focused on value and feasibility.
Yeah.
Okay, one last crucial point in this intro module. That often blurry line between requirements, the what, and design, the how.
Yeah, that's a classic tricky area. Requirements define what the product needs to do or achieve. Design is about how we're going to build it to meet those requirements.
But they often get mixed up.
They do, because in practice, you often think about both somewhat simultaneously. Design ideas pop up during requirements discussions. But the danger is imposing unnecessary design constraints as requirements.
Like saying it must be coded in Python.
Exactly. That's usually a how, a design choice, not a what, a core user need. Unless there's a very specific external constraint, of course. But generally, you want to avoid locking down the how too early.
Right, you limit the team's options for finding the best solution. So how do we keep that line clear? What questions should we ask?
Good questions to ask are things like, is this describing a specific solution or the underlying need? Are there other ways we could achieve this same outcome? Are we focusing too much on a specific technology rather than the user's goal? Is this maybe just a developer preference disguised as a requirement? Or is the client perhaps fixated on their idea of a solution instead of the problem itself? Asking these helps keep the focus on the what.
Those are great reality checks. Okay, that wraps up the intro module nicely. Let's move into module 2, client interactions. This feels like where the rubber really meets the road in understanding needs.
It absolutely is. And the number one thing always is to think about the end user when you're designing anything. These end users, plus anyone else impacted by or influencing the project, they're all our stakeholders.
And it's not just one big group of users, right? There are different types.
That's right. We usually talk about primary users, the main people using the product day to day. Secondary users might use it less often, or maybe indirectly, like someone using reports generated by the system. And tertiary users are those affected by it or making decisions about it, like the clients themselves, managers, maybe regulators.
Okay, so lots of perspectives to consider. And for those primary users, the user interface, the UI, is obviously critical.
Oh, totally critical. Good UI design makes navigation intuitive, makes the product usable, even pleasant. If it's clunky or confusing, especially if there are alternatives, users will just go elsewhere. There's a whole field, human-computer interaction, or HCI, that studies exactly this, how people interact with technology, focusing on making it effective and user-friendly.
It sounds straightforward, design a good interface, but getting the input for that, understanding user needs, that can be tricky, can't it?
Yeah, there are definitely challenges. Sometimes users just can't easily articulate what they need, maybe because they're so used to how things are now.
Right, they can't imagine a different way.
Exactly. Or they might have biases from using other systems, wanting things to work exactly like something else, even if that's not the best way for this product. And honestly, sometimes developers being so close to the tech can find it hard to really step into the shoes of a non-technical user.
That empathy gap, you forget what it's like not to know all the jargon. So how do we handle that?
Well, one useful strategy is designing for both extremes, the complete beginner and the power user. If you can make it intuitive for someone new, but also efficient for someone experienced, you generally cover most people in between.
Okay, cater to both ends of the spectrum.
And crucially, you have to consider basic human limitations in your design.
Human limitations, like what?
Things like perception colorblindness is a common example, impacting how people see visual cues. Physical limitations, left-handed versus right-handed, can affect button placement. Cognitive limits, our short-term memory is famously limited, maybe 5 to 9 items according to George Miller. So keeping interfaces simple, using familiar patterns, that helps avoid overload.
Ah, the magical number 7, plus or minus 2.
That's the one. And don't forget cultural factors. Symbols, colors, even layout direction can be interpreted differently across cultures. Translation needs are also a big one for global products.
Wow, okay. So much more than just arranging buttons. It's about how real humans perceive and process information. Now, you mentioned eliciting requirements earlier, that active engagement. What are some best practices for those client interactions?
Yeah, the key is active collaboration. You're not just passively gathering info. You need genuine curiosity to understand their underlying problems. Of course, you can get input from interviews, reviewing studies, observing users, looking at old systems, but those direct, engaging conversations with clients are vital. They also help manage expectations about what's realistic.
So what are some concrete tips for making those conversations effective?
It's definitely a balancing act. You need to be assertive enough to guide the discussion, maybe suggest alternatives based on your
Yeah.
expertise. But you also have to be genuinely open to their ideas and insights. Providing some structure helps them organize their thoughts, but you don't want to steer them too hard toward your preconceived solution.
Mm-hmm.
When a client suggests something specific, always try to dig into the why behind it. Ask how they see the user interacting with it, what problem it solves. Once you get that reasoning, then you can maybe suggest alternatives or gently point out potential issues, always explaining your thinking. Remember, they make the final decisions on requirements, but your job is to make sure they're informed.
Okay.
And crucially, revisit the requirements often. Use mock-ups, prototypes, tangible things they can react to. Keep checking in it. You're both seeing the same thing.
That why question keeps coming up. It seems really powerful for getting to the core need.
It really is. Good questions are open-ended. They make the client think deeper. Asking why, constructively, maybe a few times, often uncovers the real motivation. It's much better than just asking, so what do you want?
Hmm.
Which can be kind of overwhelming.
Yeah, too broad. And just practically, you mentioned numbering requirements earlier. Why is that useful?
Oh, it just makes life so much easier. Assigning a unique ID, even just a simple number, to each requirement lets you track it through the whole project. Referencing requirement 4.2.1 is much clearer than that thing about the user login. It helps with communication, tracking changes, everything.
Simple but effective organization. What about a glossary? That sounds like another good idea for clarity.
Huge help. A glossary is just a central list of key terms specific to this product and their agreed upon definitions. It's amazing how often different people, even in the same company, use different words for the same thing.
Right, leading to confusion.
Exactly. A glossary makes sure everyone's speaking the same language, literally.
So, clear communication, asking why, staying organized, seems like the recipe for good client interaction. Now, you mentioned specific tools for expressing requirements, like use cases. Let's dive into those.
Okay, use cases. Popularized by Ivar Jacobson. They're a great technique for identifying, clarifying, and organizing the details of how a user interacts with the product to achieve a specific goal. Basically, they tell the story of a user getting something done.
A story of interaction. So, what are the key ingredients of a use case? What goes into it?
There are several standard elements. A clear name describing the goal. The participating actors, the roles interacting with the system, the goal itself, what the actor wants to achieve, a trigger, the event that kicks it off, preconditions, what must be true before it starts, postconditions, what's true after it successfully finishes.
Okay, setting the stage.
Then the core is the basic flow, the sunny day scenario or happy path, the ideal step-by-step when everything goes right.
Mm-hmm.
The things don't always go right, so you also have alternate flows, different valid paths to the goal, maybe optional steps, and exceptions, what happens when things go wrong, error conditions, how the system handles them. And finally, qualities, any relevant non-functional requirements specific to this use case, like performance needs.
Wow, that's quite structured. And you mentioned use case diagrams too. How do they fit in?
Diagrams give you the high-level view. They visually show all the main tasks the product supports and which actors interact with which tasks. It's like a bird's eye map of the system's functionality from the user's perspective.
So diagram for the overview, detailed use cases for the specifics of each interaction. What's the main benefit of using use cases?
They really help create a clear, shared understanding of what the product does, focusing on the user's goals. That structure helps define project guidelines and organize the development work logically. By spelling out the user goals and steps, they really contribute to building something that meets actual user needs.
Okay, so use cases help define the tasks and interaction flow. What about visualizing the actual interface early on? That's wireframes, right?
Exactly. Wireframes or mock-ups, low-fidelity prototypes, whatever you call them, they're basic visual blueprints of the product screens. Their main job is just to give a tangible idea of the layout and intended function.
And why create these early sketches? What's the purpose?
Several key reasons. They help everyone, dev team, stakeholders, client, get a shared understanding of the structure and function. They're fantastic for showing clients early concepts and getting their feedback, getting them involved. They improve communication within the team too. Everyone's looking at the same visual. And for clients who struggle to explain ideas verbally, seeing a wireframe can really help them react and articulate what they're thinking visually.
And these aren't meant to be pretty polished designs at this stage, I take it.
Definitely not. Simplicity is key. No colors, no real images, no fancy fonts. Just focus on the basic functions, the user tasks. Where do buttons go? Where are the text fields? Navigation. It's like an architectural blueprint. You see the room layout, doors, windows, but not the paint color or furniture.
Structure over style. And when do you typically create these?
Usually pretty early,
Yeah.
soon after those initial requirements discussions. Then you show them to the client, get feedback, make sure everyone's aligned on the basic structure and flow before you invest a lot of development effort. That early feedback loop is crucial.
Catch misunderstandings early. Makes total sense. Now, another visual tool. Storyboards. How are they different from wireframes?
Storyboards are also visual, but their main focus is showing the sequence of user actions over time to achieve a goal. They tell a visual story of the user's journey.
And there are a couple of main types.
Yeah, generally two. First is the high-level user experience storyboard. Think of it like a comic strip showing the whole end-to-end interaction. Starts with why the user decides to use the product, goes through the steps, ends with the outcome.
Okay.
You might have one for each major feature. Often uses personas, those detailed fictional user profiles, to make it more concrete. This hook is great for getting the whole team aligned on the overall experience, spotting improvement areas, keeping the vision user-focused, even for demos.
You mentioned a pizza example earlier. How would that look as a high-level storyboard?
Right, Brampton's Pizza. You'd have panels showing family deciding they want pizza, someone browsing the app, selecting toppings, checking out, getting confirmation, maybe tracking the delivery on a map, and finally happily eating pizza. It captures the whole journey.
Got it. The big picture user journey. What's the second type of storyboard?
The second type is more detailed, focusing on the UI interaction itself. It basically combines wireframes with the steps from a use case's basic flow. It shows each screen state as a wireframe, with arrows indicating how the user interacts with specific UI elements, clicking a button, filling a field to move to the next state.
So zooming in on the screen-by-screen flow.
Exactly. This detailed type helps designers nail down the precise UI elements and transitions, spot usability issues in the flow, make sure the team understands the intended look and feel, and can even help with writing user manuals later.
So one for the overall experience narrative, one for the detailed interface steps. Very useful distinction. And plenty of tools to help create these, I assume.
Oh yeah, loads. Anything from simple stuff like Google Docs or PowerPoint for basic diagrams to dedicated wireframing tools like Balsamiq or OmniGraffle, even online tools like Wirefy that can generate wireframes from websites. Depends on the need and the team's preference.
Great. Okay, we've covered client interactions and visual tools. Let's move to Module 3, writing requirements, shifting from visual to more formal text.
Right, because while visuals are great for understanding, you still need well-written requirements for clear documentation and guiding development. And in Agile, there's a particular way we approach this.
Agile requirements. We touched on Agile embracing change. How does that apply to writing requirements?
Well, the core idea in Agile, coming from its principles, is that software development is dynamic. Requirements will change, even late in the game. Agile embraces this, seeing it as a chance to deliver more value. So lots of face-to-face interaction, close collaboration with clients is key to stay aligned as requirements evolve. This fits right in with that collaborative elicitation we talked about. It's fundamental to methods like Scrum. The product manager plays a big role here, constantly refining the vision and managing scope in this iterative way. Following Agile principles when creating requirements generally leads to higher quality software that really meets customer needs better.
So embracing change through constant collaboration. And a key technique for writing requirements in Agile is the user story.
Yes, user stories are super common in Agile. They're a way to express requirements concisely, consistently, and in a format that everyone, technical or not, can easily understand.
And they have that standard structure, right? As a I want to, so that format.
Exactly. As a who, that's the user role or stakeholder. I want to, what's, that's the desired action or function. So that why, that's the motivation, the benefit they get.
Can you give an example?
Sure. As a restaurant diner with allergies, the who, I want to filter the online menu by ingredients, the RUD, so that I can quickly find safe dishes to order, the why.
Perfect. That structure really forces you to think about the user, the action, and the value. What are the other benefits of using stories?
Well, that clear structure makes them easy to write and understand without getting lost in technical jargon. They're usually short and focused. Easy to organize, too. Historically, people literally used index cards, easy to shuffle around.
Right, physical cards.
Yeah. And while ideally clients help write them, often product managers facilitate, helping phrase them correctly and making sure they fit the overall vision.
Okay. Simple, structured, user-focused. Now, I remember hearing about INVEST as a checklist for good user stories. What does that stand for?
Right, indest is a great mnemonic. Independent, the story should stand alone as much as possible. Negotiable, it's a starting point for discussion, not a fixed contract. Valuable, it delivers real value to the user or business. Estimatable, the team can roughly estimate the effort needed. It's small enough to be completed in a short iteration like a sprint. And testable, you can define clear criteria to verify it's done correctly.
That's a really practical set of checks. What if a story is too big or vague? You mentioned epics before.
Exactly. If a story fails the estimatable or small test, it's probably an epic. An epic is just a large, high-level user story. You see them a lot at the start of projects when things are still a bit fuzzy, that cone of uncertainty.
So an epic needs breaking down.
Precisely. Like, as a customer, I want to pay online. That's an epic. It needs breaking down into smaller stories like enter credit card details, confirm billing address, receive email confirmation. You identify the epics and slice them into manageable, invest-compliant stories. And remember, the story itself should have just enough info to start, not all the technical implementation details.
Break down the big goals into smaller, testable steps. Got it. You also mentioned acceptance tests linked to that testable part of iNest. Tell me more about those.
Acceptance tests are the specific checks used to verify if a user's story is truly done. The story passes if the tests pass. These tests come from the acceptance criteria.
Okay, and acceptance criteria are?
They are the simple, specific conditions that must be met for the story to be considered complete. Clear language, unambiguous, usually driven by the client's specific needs.
Right.
To turn criteria into tests, you just think through the actual steps to verify them. So if a criterion is system accepts Visa cards, the test is try paying with Visa. Does it work?
So criteria define done. Tests are how you prove it. What are the benefits of having these?
They make sure everyone agrees on what done means from the user's view. They often surface hidden details not explicit in the story. They give developers a clear checklist. And, like we said, if one story has tons of acceptance criteria, that's a big hint. It's probably an epic needing splitting. And again, creating these should be collaborative client, product manager, team, all involved.
Collaboration, always key. Okay, so we have user stories, acceptance criteria. How do we organize all this work for development?
That's the job of the product backlog. It's basically the master list prioritized of everything planned for the product. Features, user stories, technical tasks, bugs, everything.
The big to-do list for the entire product. What's its main purpose?
To organize all the work, prioritize it based on value and dependencies, and serve as the input for planning development iterations, like sprints and Scrum. It's central to Agile because it's flexible and always evolving. Items near the top are usually more detailed. Further down, they might be less defined.
How do you build and manage it?
It starts by listing all the known user stories and other items, giving each a unique ID. Then comes prioritization, and this is crucial. It's an ongoing discussion involving the client, the product manager representing business value, and the dev team giving input on effort and feasibility. This clarifies what's most important and the value versus effort trade-offs.
And the dev team uses this prioritized list how?
They pull the highest priority items from the top of the backlog to work on in each sprint, aiming to deliver a working piece of the product each time. The beauty is the flexibility. While the current sprint's work is usually fixed, the backlog for future sprints can change based on feedback, new insights, shifting priorities. It allows continuous adaptation.
A living document guiding development. Now, you mentioned one more tool here, story maps. How do they compare to a backlog?
Story maps offer a more visual, holistic way to look at the backlog. Instead of just a linear list, they organize stories in a way that reflects the user's journey through the product. They're great for seeing the big picture, understanding flow, and discussing scope.
How are they usually structured?
Typically, it's a grid. Across the top, you have the major steps or activities in the user's journey, in sequence. Then, under each activity, you list the relevant user stories vertically, ordered by priority most important at the top.
Ah, so it lays out the user flow and prioritizes stories within each step. What are the advantages?
Loads. It makes prioritization feel more intuitive because you see stories in context. It gives a visual grasp of the whole product, making it easier to spot gaps or dependencies. It helps the team see the bigger picture, suggesting a logical flow for implementation, maybe building a thin slice across the whole journey first. It encourages a user-centric view, not just isolated features. It really helps visualize how the product will grow over time. But just to be clear, it's not a Kanban board tracking task status, and it's not a full project plan. It's a planning tool for organizing stories in the context of the user experience.
That's incredibly useful for shared understanding and planning. Okay, final module. Quality requirements. We know how to write them. How do we ensure they're actually good?
Yeah, the million-dollar question, right? High-quality requirements are essential. They guide development accurately, prevent mistakes. They need to be complete, no missing pieces, and clear, easily understood, no room for misinterpretation.
We talked about Einvest for individual stories. Are there broader quality criteria for the whole set of requirements?
Yes, definitely. Beyond invest, think about these. Requirements must be correct, truly reflecting the client's vision. Incorrect ones just waste time. They need to be complete, covering all necessary aspects. Story maps can help find gaps here. They must be clear. Easy to understand, only one interpretation. Ambiguity is the enemy. Reviews and visuals help here. Consistent, they shouldn't contradict each other. Feasible, realistically implementable within project constraints. Tech, budget, time. Unfeasible requirements just lead to frustration. And traceable, each requirement linked through the lifecycle to design, code, tests. Usually done with those unique IDs we mentioned. Traceability ensures everything needed gets built and tested.
Traceability sounds critical for accountability, making sure nothing falls through the cracks. Now, ambiguity. You flag that as a major threat. What exactly makes a requirement ambiguous?
It's ambiguous if it can be interpreted in more than one way, or if it just lacks the specific detail needed for clear understanding. This fuzziness leads to miscommunication, wrong implementations. Avoiding ambiguity saves so much time and money.
And you broke down common types of ambiguous words, which is super helpful, especially for non-native English speakers listening. Let's quickly recap those. Indirect language.
Words like should, could, may, might, often, usually, as appropriate. They're fuzzy about when or if something happens. Does should mean must. Does may mean sometimes. Needs specifics.
Be direct and specific about conditions. Vague words.
Verbs like processed, handled, managed, supported. Nouns like item, data, system. Phrases like user-friendly. What do they actually mean in this context? Need concrete definitions, maybe from the glossary.
Precision in verbs and nouns. Completion words.
Things like and so on, etc. also. They imply an incomplete list or unclear additions. Better to list everything explicitly or ensure the context for also is crystal clear.
Avoid open-ended lists. Persuasion words.
Clearly, obviously, easy to use. These state opinions, not facts. Requirements should be objective.
Stick to the facts. Qualifiers.
All, every, only, none, never, always, sometimes. Prone to overgeneralization or misplacement. Only is famous for changing meaning depending on where it sits in the sentence. Be careful with scope.
Watch placement and scope. Comparatives.
Same is better than error, est, better how, faster than what. Need to specify the attribute being compared.
Define the comparison basis. Quantities.
A, some, most, few. How many exactly? Which items? Need specific numbers or clear identification?
Be precise with numbers. Pronouns.
It, they, this, that. Can be unclear what they refer back to. Often safer to repeat the noun for clarity in technical writing.
Clarity over conciseness sometimes. Positional words.
After, before, last, next. Ambiguous about sequence if context isn't precise. Immediately after, sometime after. Be specific.
Define the sequence clearly. Temporal words.
When, for, until, current. When exactly, for how long. Need precise timing and duration.
Nail down the timing. And finally, joining words.
And, or, both. Can create confusion about conditions. Does and mean both must be true or just connects options? Does or include both? Sometimes clearer to split complex conditions into separate requirements.
Watch out for complex logic. Well, that's a minefield of potential misunderstandings just in common words. So besides awareness, what can we proactively do to fight ambiguity?
Well, actively review requirements specifically looking for these kinds of words. When you find one, challenge yourself. Can I make this more precise? Rephrase it. Another great technique. Try replacing terms with their definitions from your project glossary. Does the sentence still make sense? Is it unambiguous? Maybe the glossary definition needs refining too.
Using the glossary as a check.
Exactly. And probably the most important thing, never ever hesitate to ask clarifying questions. If something seems fuzzy or could mean multiple things, ask the client, ask stakeholders, what exactly do you mean by processed here? When you say usually, under what conditions? A quick question up front saves massive headaches later.
Fantastic advice. Proactive clarification is key. Well, that brings us towards the end of this really comprehensive exploration of client needs and software requirements.
Indeed. We've covered a lot of ground from what a requirement even is, the activities involved, the different types, those crucial client interactions, methods like use cases, wireframes, user stories, how to ensure quality, and tackling change and ambiguity.
It really hammers home how vital this initial phase is. Getting that understanding and definition right is just paramount. It's the foundation for everything else.
Absolutely. And hopefully, by understanding these principles and techniques, you, the listener, now have a kind of shortcut to being much better informed about this critical part of software development. It equips you to help build the right product the right way.
So here's a final thought to leave you with. How might these principles we've discussed, the focus on clear communication, really digging deep to understand needs, defining goals precisely, how might they change how you approach understanding needs in your own work, even outside of software? Think about the power of clear goals and communication in any project you tackle.
Yeah, we definitely encourage you to think about that and maybe dive deeper into any areas that particularly caught your interest. That skill of translating needs into clear, actionable plans, that's valuable absolutely anywhere.